Hello, my dear students. In this lecture, we are going to see one previous year GATE numerical. This question was asked in GATE 2014 for 2 marks in set 4. And basically, this question is based on conduction topic. And again, specifically, this question is based on the heat transfer through a plane slab. So let us understand the question. The question is, a plane wall has a thermal conductivity of 1.15 watt per meter Kelvin. Now, my dear students, here they have mentioned the plane wall. So let us first draw the diagram of plane wall. Let us say there is a plane wall like this, right? This is a wall. Now, for this wall, let us say it is having thermal conductivity K. The wall is having thermal conductivity K, and they have provided the value of K, which is nothing but 1.15 watt per meter Kelvin. 1.15, right? This value they have provided for thermal conductivity, right? If the inner surface is at 1100 degrees Celsius and outer surface is at 350 degrees Celsius, now here the inner surface temperature for the wall and outer surface temperature for the wall are given in degrees Celsius. So let us say here this is the inside surface which is at temperature T1 and outside surface which is at temperature T2. So my dear students, they have provided values for T1 and T2. T1 they have provided 1100 degrees Celsius and T2 they have provided 350 degrees Celsius, right? These are the values. Then the design thickness in meter of the wall to maintain the steady heat flux of 2500 watt per meter square should be. Now then, what will be the thickness, this design thickness of wall? Let us say this thickness we are representing with B, right? Then what will be the value of this B, right, in meter? In meter, to maintain the steady state heat flux. Now they have provided the value of heat flux which is 2500 watt per meter square. The heat flux is nothing but Q, which is nothing but heat transfer rate per unit area, which is nothing but 2500 watt per meter square, right? So my dear students, for such type of cases, very simple case, it is a simplest case of plane wall, heat transfer through the plane wall. Now heat always flows from the high temperature to low temperature. As it is steady state, therefore heat flows from here T1 to T2, right? And my dear students, we have derived this formula. Here, as heat is flowing through this wall will offer some resistance. Therefore, there will be a R conduction. For this conduction, this wall will offer a resistance, and the resistance offered by the wall is nothing but B divided by Ka, right? That formula we have derived. The resistance offered by the wall is nothing but B divided by Ka, right? Where A is a area perpendicular to the direction of heat flow. Here this area we can consider. Here this area perpendicular to the direction of heat flow. This will be area, right? And my dear students, B is the thickness of wall, K is the thermal conductivity of wall, right? And this heat transfer through the wall, Q is nothing but, let us say capital Q. If I write this capital Q is nothing but del T divided by resistance through the device, right? Therefore this Q is equal to del T is nothing but temperature difference, that is T1 minus T2 divided by resistance is divided by B by Ka. This will be the resistance, right? And if I consider this area on the left side, it will become Q by A, right? Q by A, which is nothing but heat flux, will be equal to T1 minus T2 divided by B by K, right? Now let us put the values, because here Q is given, T1, T2 is given, thermal conductivity is also given, B is a question, right? So let us find this B. Therefore, my dear students, let us put the values. Therefore, this Q will become equal to K T1 minus T2 divided by B. Therefore, this B, thickness of the slab, will be equal to, or wall will be equal to K T1 minus T2 divided by Q. So let us put the values. Thermal conductivity they have provided 1.15 into temperature T1 is 1100. Temperature T1 is 1100 minus temperature T2 is 350 divided by heat flux is given 2500. Now my dear students, if I put all these values, then I will get this thickness of wall which is equal to 0.345 meter, right? As we have kept all dimensions in meter, look at the thermal conductivity, it is watt per meter Kelvin, right? Heat flux watt per meter square, right? So all dimensions are in meter, so the thickness will be in meter, and here they are asking in meter only. In the question they have mentioned to find in meter only. So here in the fill in the blanks you have to type 0.345 4, 5 for getting 2 marks. Thank you, dear students. In next lecture, we will see one more numerical on this topic, which was asked in previous year GATE examination.